making contour maps or other diagrams, whether an air pressure map, as we'll do here, a temperature map, a map of elevation called a topographic map, or oceanic depth called a bathymetric map, or a map of virtually any numeric value versus geographic position, such as population density, crime rates, land reflectivity, percent of a particular color rock, chemical composition, almost anything, can be a huge help in understanding processes and properties of whatever is being studied. But many people are intimidated by the process of creating the contours. But by following a few simple and logical rules, these maps can be made with just a bit of care. Below are a set of rules of contouring along with the methodology used to make the contour lines. The particular map we'll make is an air pressure map and thus has a few specific rules for the meteorology field, but the general principles are the same for any contour map. A link to a practice contour map is included, as well as a link to a YouTube video based on it. This is something that I did for a living when I worked for an oil company many years ago, but the principles really are the same for making any kind of a contour map at all. There's a very few simple rules for contour lines, and these specifically are for meteorology. I'll eventually put together a contouring video for bathymetry and for topographic maps, but they're largely the same. First of all, a contour line must never divide or split. And by that, I mean you'll never see a contour line do something like that, because since contour lines separate areas of higher versus lower, in this case, since it's an air pressure map, higher versus lower air pressure, what can that be? It's ambiguous. So you can never have a contour line split or divide. Or the opposite of that would be come together. Another issue is a contour line must never simply end. If you have a map, and suppose this is your map, and you have a contour line going from one margin to another, it will always come around somewhere else and join to enclose an irregularly circular region. It might go like that, it might go like that, but it will never simply end. You'll never see a contour line simply end like that and then have other contour lines around it. It's not possible. Number three is really more of a question of avoiding errors. The contour line must represent one and only one value of air pressure, temperature, elevation, etc. Sometimes I've seen people drawing contour lines, a whole series of contour lines like this, and as they label them, they might have this one to say be 1,000, 1004, 1008, like that. And they'll follow these around and they'll lose track. And they'll start calling this 1004, 1008, 1012, something like that. And this is obviously, since the definition of a contour line is a line representing one air pressure, temperature, elevation, something like that, you can't have two values associated with it. So this is simply a matter of making mistakes, so you want to avoid that. Number four, a contour line may never intersect another contour line. If you have, say, an air pressure contour where this is 1,024 millibars and another one of 1,028 millibars, what's that? It cannot be two values of air pressure at the same time. So the only time that this is possible is if you have an elevation map and you have a vertical cliff, but this will never happen with an air pressure map. Number five, closely spaced contour lines indicate a steep, in the case of air pressure, pressure gradient. If they're widely spaced, that indicates a gentle gradient. In other words, if you have an area where you have contour lines that are close together and then suddenly they're far apart, remember that this is a map and you have horizontal distance as you move along the map, so that over here air pressure does not change much, and so that would be considered a gentle gradient of pressure, whereas here pressure is changing rapidly, and so we call that a high gradient, or a steep gradient of, in this case, air pressure. Number 6, concentric circles of contour lines indicate either a high pressure zone or a low pressure zone, or depending on what you're looking at, it might be high or low pressure, high or low elevation, something like that. And so if you see a series of concentric contours like this, you will always, if you look at the numbers, you will see something like 1016, 1012, 1008, and obviously that means that this is a low pressure zone, and you would wind up putting an L there to indicate that this is a low pressure zone. On the other hand, if you saw that the air pressure values were increasing, say from 1008 to 1016 to 1020, obviously air pressure is increasing, and this would be labeled as a high pressure zone. If this was elevation and you were going from 1008 feet to 1016 to 1012, oh, and I left one out, I left out 1012. If you were increasing in elevation, obviously that would be a hill. If you were decreasing, that would be, in Florida, something like a sinkhole or some lower point of elevation. Another important factor, which unfortunately I missed there, number 7, numbering on contour lines will always be evenly spaced apart. In other words, you won't skip values. It's very difficult to interpret a map that doesn't have constant contour elevation changes or contours in general. And so you notice that in most cases I was showing changes of 4 millibars, air pressure values of 4 millibars from one contour line to the next. In meteorology, the air pressure by convention changes by 4 millibar intervals. In contour maps of elevation, it varies depending on the amount of relief of a map. If you have a place, for instance, such as Florida, where elevation doesn't change very much, you might have new contour lines every 5 feet. If you are in a place like the Grand Canyon, where the total elevation change is about 5,000 feet, putting a contour line every 5 feet would give you 1,000 contours, which would be very difficult to recognize anything. The map would be entirely blackened by the contour lines. And so you might have contour lines every maybe 200 feet to give you a better sense of what kind of elevation changes you are. Again, by convention, meteorological air pressure maps are always every 4 millibars, and to make it so that you can recognize them and standardize them, the numbering on the isobars will always be divisible by 4. And because 1,000 is divisible by 4, this is a convenient benchmark. You'll go from 1,000 to 1,004, 1,008, 12, 16, 20, and so on. And then you'll go down from 1,000 if you have low pressure areas from 1,000 to 996, 992, 988, 984, 980, and so on. Contour lines are usually subparallel, and this is really not a contouring rule. This is just a general rule of the way that reality works. What this means is that generally you will not have contours that are completely different from one another like that. Instead, what you will see is that contours, because landscapes and air pressures generally change gradually, you'll see things like this. These are not exactly parallel, but they are subparallel. In other words, each successive contour line somewhat resembles the contour line next to it. Rule number 10, contour lines must honor the data. This is a critically important rule for contouring. If you have a contour line, or say two contour lines of 1,000 millibars, 1,004 millibars, what that means is that this line of constant pressure and this line of constant pressure define places where the air pressure is equal along that line. And therefore, in between any values of measured air pressure between these two contour lines will be between 1,004 and 1,000 millibars. And so you might see a 1,002 millibar point there. You might see a 1,003 millibar point. You might see a 1,001, but you will not see a 1,006 millibar. 1,006 millibars will be on this side of the 1,004 contour, and all values on the other side of the 1,000 millibar contour line will be less. You might see 997, you might see 998, something like that. But you will not see anything higher than 1,000 here. You will not see anything lower than 1,004 over here. Number 11, nature curves smoothly rather than in a series of short straight lines, and your contours will do the same. Many times beginners who are contouring will draw a series of straight lines like this, and nature, whether it's air pressure, elevation, temperature, does not generally do that. You would see something like that. That would be a much more realistic contour line. And the last thing is not always shown in commercial contour maps of, say, elevation, but a good general practice as you are learning how to make contours is to always label your contour lines. If you have a series of contour lines, always label them, and don't just label them once. Try to label them as you move along the contours so that you don't lose track of what each individual contour line means. And so if this was, say, 1,000 millibars, you might go along for a while and then label it 1,000 millibars over here and then 1,000 millibars over there. This might be 1,004, 1,008, 1,012, and so on. And then as you went along, you would label them. This is a little close, but you want to be able to have them labeled frequently enough so that you don't lose track of how these contour lines are made. Okay, so those are the general rules of how you would contour a contour map. What about the specifics of the methodology